This conference will now be recorded.
Thank you for joining with us today with Live Talk. We have Dr. B back in the studio today, as well as our guest speaker, Dr. Doug Smith, and we are going to talk about the autonomic parasympathetic today. So, Dr. B.
Okay, and thank you, Chrissy. And anybody who needs to get in contact with us during during the show, they can just go to their phones, and up on the right-hand corner is a place where you would go ahead and click on, and you will see that you can type in any kind of question that you would like to ask. And thank you very much. And here comes Dr. Smith. Hi, Dr.
Yeah,
Smith.
yeah, I'm in my car, so I'm trying to get my camera situated, and it looks like it might hold still right there.
It looks good.
It's not moving. All right, we'll go with it. B, what are we
We
talking
left
about
off
today?
at the autonomic nervous system yesterday, so I thought you might want to start with that. So I thought maybe we would put up the picture for the autonomic nervous system,
You're
and
talking about the somewhat medical-looking diagram that shows the autonomic nervous system, and it's divided into the sympathetic and the parasympathetic branches. Is that the graphic you're
exactly.
referring to? All right.
Yes.
Let me know. Let me know when you can see the graphic, and
Okay.
we'll start a discussion about the graphic. Uh,
All right. There it is.
this is something that people don't think about. Why would you think about something that's automatic? I mean, part of the reason you make something that's automatic is so that you don't have to think about it. When you put something on automatic payment, that's so you don't forget, and the system works. Although technically, you got to be careful here. The name isn't automatic nervous system; it's autonomic nervous system. So don't get caught on the words. But people don't give a lot of thought into the control of their organs and organ systems. You people that are watching us are sitting there right now, and they're not thinking about what their respiratory rate is. They're not thinking about what their heart rate is. They're not thinking about whether their sweat glands are active or not active. They're not thinking about whether or not they're digesting their breakfast or lunch or whatever it may be. Those things occur without conscious effort. Okay, and in fact, before intelligence and consciousness could really flourish on this planet, you had to have a system by which the organs were stable. You can't if your organs aren't stable, you as an organism and you as a life form, you're not going anywhere. Okay, not until you get your organs stable. So stabilization of the organs is an absolute imperative in this life process. And so Mother Nature designed one system that's divided into two components. Uh, and it really has to do with what the state of the organism is at the time. One of the systems we know lovingly as the rest and digest system, and one system we know lovingly as the fight or flight system. You're driving down the road and a soccer ball rolls out in front of you, and a kid comes running out the road to grab the soccer ball. And you slam on brakes, and you get that surge of adrenaline and that rush, and your heart rate goes up, and that's the fight or flight. Okay. After lunch, you get sleepy, lay down, take a nap, and that's the rest and digest. And generally speaking, one or the other is in control at all times. You don't want a whole lot of fight or flight. You want a whole lot more rest and digest. And hadn't really none of us had really thought about it, but it would make sense that since this is an old and ancient type of nervous system, that the old and ancient nerve receptors are involved, and very few nerve receptors are more ancient than the opioid receptors. So for the opioid receptors to have a role in the fight or flight, well, that makes sense. And plus, if the bear bit you and it hurt, well, let's make sure we activate the fight or flight. So to have a pain receptor involved in this process is not it doesn't catch it's not unusual. Okay, and that's what it looks like has happened here. Is we've gone through a lot of time and effort to explain in detail how the opioids caused a poisoning in the DNA. In fact, if we could, and let's take our time here, let's not move too quickly, but if we could take the graphics all the way back to the first of the two DNA slides that we looked at, and yeah, right here, okay, this is our data. Love going to this slide, love looking at this slide. I've spent a lot of time looking at this slide. I spent a lot of time designing the clinical trial that resulted in this slide. So this is near and dear to my heart. And as we see here, the top 5 people, those are opioid naive. They have normal DNA, and everybody from 6 all the way down, that's people who are opioid dependent. These are people who have been, their DNA has been poisoned by the opioids. And in fact, you are looking right at the poisoning. So if there's any disbelievers out there, any science disbelievers, okay, kind of hard to deny what you're looking at right here. Okay, the DNA of the opioid dependent and the DNA of the opioid naive are clearly different. In fact, you're looking at it. Okay, now I'll grant you the differences are huge, and we'll talk about why here in just a second. So if we could jump forward to the next slide, the second DNA slide, and what we're looking at here now you want to talk about a complex slide. Okay, this will do for complexity until complexity shows up. I'll tell you what, this is a complex slide, and we need to be honest about that. This slide is intimidating when you first look at it, okay? But if we spend a little time talking about it and looking at it, this slide becomes easier and easier to understand. What you're looking at here is how the genetics people talk to each other. This is their language, okay? And on what you see on top there, that is one gene. The name of that gene is OPRM1 gene. OP, opioid, R, receptor, mu1, OPRM1 gene. Okay. And what you see down below there, you see these little blue and red columns. Each blue has a red. Everywhere that the red column is bigger than the blue column, that is a place on the DNA where the poisoning turned off that piece of DNA. That's how the opioids do their damage. The opioids cause a process called methylation. Methylation shuts off the area of gene of the DNA under the methylation. It's called gene silencing. And that's what you're looking at right here. So what you see all up and down this gene are different areas where stuff got shut off. A whole lot of areas got shut off. Everywhere that the red is bigger than the blue, the area of DNA under those columns got turned off. And as we looked and saw last time, there's a little red area there called the promoter region. We talked about how that's the circuit breaker. And if you start switching off things in the circuit breaker, well, things aren't going to work normally. So let's jump back to the autonomic dysfunction, autonomic nervous system right here. So that gene, the one you just looked at, the one that had the poisoning, the one that had the areas of the DNA turned off, that gene is evidently involved in control of what you're looking at right here. That's why we're showing this slide. So a little bit of common sense now. If you've got a opioid receptor, if you've got a nerve receptor, if you've got one of the components, one of the parts, where you shut off a whole bunch of the DNA, you turned it off permanently, okay? You turn off enough areas and you get to a point where that receptor is not going to work normally. And if that receptor is not able to work normally, then what you're looking at right here is one of the areas in the body that are going to be impacted by a dysfunctional receptor. One of the areas in the body that are not going to work normally because the receptor was built in a way that it's just not normal and it can't do what it's supposed to do. And so if this opioid receptor can't maintain balance between what you're looking at right there, if this opioid receptor cannot maintain balance between the parasympathetic and the sympathetic nervous systems, if this opioid receptor cannot maintain balance between the rest and digest and the fight or flight, well, then if these systems go out of control, that's going to be distressing for the individual. And now what I want the people to do, the people, if you've ever been in opioid withdrawal, okay, and my guess is most of our listeners and viewers have been in opioid withdrawal, I want you to stop the video and I want you to look at the individual organs involved. I want you to see the sweat glands. I want you to see the hair follicles. I want you to see the heart. I want you to see the gut. I want you to see how many organs and organ systems were involved that were not functioning normally, and look at opioid withdrawal. Okay, in fact, let's take a moment here and let's look at if we can pull up what's called the COWS scale, COWS. And Dr. B, you know as well as I do that the COWS scale, COWS, Clinical Opiate Withdrawal Scale, okay, that's what's been used for decades to measure how far into withdrawal any one individual is. And now let's look at the list of symptoms here after we looked at the autonomic nervous system, sympathetic, parasympathetic, rest and digest, fight or flight. Let's just look at the list of symptoms here. And I believe, yeah, okay, I can blow this up on my screen. All right, so the first one you see there, okay, pulse rate. Well, you saw that the heart was involved in the autonomic nervous system, okay. Um, Second one you see there, chills and flushing. Okay, well, you saw how the autonomic nervous system was going to the skin. Okay, so that's easily explained by a dysfunction in the autonomic nervous system. And the third one there, dilated pupils. Okay, well, you saw how the autonomic nervous system was involved in the eyes, the pupils. Next one you see there. Um, oh, I missed one, and that was the can't sit still. We'll come back to that one. All right. I am having a hard time reading this. Anyway, I don't need to read it. We all know it by heart. I asked the listener to go through this list in detail, and what you'll see is that this list of symptoms that people have experienced in opioid withdrawal, it's nothing more than a dysfunction in the autonomic nervous system. In fact, let's bring the viewers' attention to a couple of three uh, uh, symptoms here: rapid heart rate, pouring sweat, dilated pupils, and yawning. Now you can see where the yawning comes from, the rest and digest. And you can see where the big dilated pupils and the pouring sweat and the rapid heart rate comes from the uh, uh, sympathetic nervous system, the fight or flight. Well, I'm gonna tell you something. Okay, Mother Nature has spent hundreds of millions of years making sure that an organism with big dilated pupils, pouring sweat, rapid heart rate isn't yawning. Okay, stop and think about it. Yawning while your heart's pounding, you're pouring sweat, your eyes are dilated, not possible. Simply not possible. Okay. In fact, I'll go so far as to say those symptoms cannot occur together unless you have genetic damage. So let's stop for a minute and look at where we are. We saw the genetic damage. We saw the significant number of areas where the DNA had been turned off. Okay, what's called gene silencing. We looked at the autonomic nervous system and all the organs that it controlled. And now we're looking at what a dysfunction within that autonomic nervous system would look like. So if you listen to what the psychiatrist and the mental health expert and the addiction expert, if you listen to what they're telling you, number one, they're telling you opioid withdrawal won't hurt you, won't kill you. We'll come back to that because that's a very serious subject. And they're also telling you that oh no, you're just craving to get high. Wait a minute. You're pouring sweat, your heart's pounding, your eyes are dilated, you're yawning, and you're just craving to get high? That doesn't even make sense. I mean, they are just ignoring. Number one, they're ignoring the damage to the DNA, okay, which is not a good idea. Okay, so my advice to you people out there in the mental health world is stop ignoring the damage to the DNA. Okay, you're just looking foolish. Stop ignoring the damage to the DNA. The people are figuring it out. Okay, you don't look like the experts anymore. You look foolish. You ignored science. You ignored the damage to the DNA. We just looked at it. Everybody that's listening to this video just saw it. Okay, they saw the raw data. They saw the people who had donated DNA so that we could do this study, and they clearly saw that the DNA of the opioid dependent is not the same as the DNA of the opioid naive. And people clearly saw all up and down that gene, all up and down that OPRM1 gene, all up and down that gene that makes the opioid receptor. They clearly saw areas that had been turned off, and common sense would tell you, you turn off that much DNA and your opioid receptor is not going to be normal. Come on, how could it be? Plus, you turned off a whole bunch of areas in the promoter region, which we refer to as the circuit breaker. Okay, if you turn off that many areas of DNA, and you're looking at it right there on the screen, you turn off that many areas of DNA, and you are not going to have a normal receptor. It's just no way. So if you don't have a normal receptor, and if that receptor, as we believe, is involved in maintaining oversight of the autonomic nervous system, then your autonomic nervous system is going to be all haywire. When you attempt opioid abstinence, when you attempt to stop taking the opioids, our people lose control of their autonomic nervous system. Now, let's talk about this for a minute. You lose control of your sweat glands. That's uncomfortable. You lose control of your bowels. That's distressing. You lose control of your adrenal gland, where all your adrenaline is stored. You lose control of your adrenal gland, and that little thing will kill you. You lose control of your adrenal gland, and you will have adrenaline toxicity. And if you have adrenaline toxicity, one of two outcomes: you're either going to die, well, actually, one of three outcomes. You're either going to die, you get yourself out of withdrawal, or your adrenal gland runs out of adrenaline. Okay, so if we're right, and we are, if we're right, then we should see high levels of adrenaline in people while they're in opioid withdrawal. So if we draw blood on people while they're in opioid withdrawal, we believe we're going to see very high levels of adrenaline. Okay, if we're wrong, and this thing is a mental health issue, okay, then the adrenaline levels should be normal. So we can do a blood test and we can learn a lot. In fact, let's talk about what we can learn. Okay, if this is a mental health condition, the adrenaline levels will be normal. Why will they be normal? Because it's mental health. That's kind of the definition of mental health. If this is a mental health condition, then the blood levels will be normal. Okay, we don't believe it's a mental health condition. If this is a loss of control of the autonomic nervous system, and one of the organ systems out of control is the adrenal glands, then we should see high and toxic levels of adrenaline. Now, if we see high and toxic levels of adrenaline will kill you. Cardiovascular collapse, heart attack, strokes, adrenaline will kill you. No two ways about it. And even if you survive, adrenaline will change your brain. Okay, so Dr. B, do we have time to at least look at the results of the catecholamine toxicity in our study?
Yes, sir. We have at least 10 more minutes.
Okay, all right, Dr. B.
Yes.
Now that we have the luxury of 10 minutes, let's use our 10 minutes very, very wisely. Okay.
Yes.
Dr. B, am I coming through clearly? Am I making sense when I say let's look at the blood work, and if it's a mental health condition, then we should see normal levels of adrenaline, and if it's not a mental health condition, if in fact it's a loss of control of the autonomic nervous system, and that one of the organs that's out of control is the adrenal gland, that we should see high levels of catecholamines. Am I making sense?
Yes, and since you have gone ahead and you've done people that have never had a opioid, and they're the control group, and then you've done the people who have had opioids, and they're the people who are positive, you have it's very, very clear that the people that have had opioids have damage to their DNA, where the other people have no damage at all.
B, you're right. In our study, we drew blood on a number of different groups of people. And Dr. B, if it's okay with you, I'd like to take tomorrow and go through those groups and the differences in those groups in depth. But at least for today, can we at least look at the catecholamines on the individuals who were opioid dependent, that were very brave, These are very brave volunteers. These people volunteered to stop all opioids and come into the clinic on day 3 and have their blood drawn. Day 3, 3 days of withdrawal, three days of no opioids. Now, to people who have never experienced opioid withdrawal, that sounds like no big deal. I didn't take opioids for 3 days, big deal. But to people who have opioid dependency, 3 days of no opioids puts you in a horrendous position. Now,
There you see right there the people who are on opioids. We have another scale that shows the people who are not on opioids.
now what you're looking at there, B, is you're right. You're looking at people who are opioid dependent who have stopped their opioids.
Yes, sir.
Right. These are people who have stopped their opioids for 3 days. Now, if you stop your opioids for 3 days and you have and if you're diagnosed with opioid addiction or opioid use disorder, if you stop your um, opioids for 3 days, your blood work should be normal because it's a mental health condition. Okay. If you went to your primary care provider and said, I think I'm depressed, okay, before that primary care provider is going to give you a diagnosis of depression, that primary care provider is going to say, all right, well, maybe you are, maybe you're not. Let's check some blood work and make sure your blood work's okay. Let's check your hemoglobin, make sure you're not anemic. Let's check your thyroid, make sure you're not low thyroid. Let's check some things, okay? And a good provider is not going to give a mental health diagnosis until the blood work is normal, okay?
Well, you would
Dr. B,
think that. I mean, you would think that anybody would check the blood work before they had a diagnosis.
well, Dr. B, that's the amazing thing, and this isn't something we're proud of. We're the first people in the history of the world to check this blood work on people who were in opioid withdrawal. Okay, we were the very first people to draw blood on volunteers who stopped taking their opioids. Now, I'm not particularly proud of that because what that means is it means that the entire medical community has failed these people. The entire medical community it is horrendous what has been done to these people. They're not opioid addicts. They don't have opioid addiction. The opioids are a defective product that damage their DNA, damages the DNA. They lose control of their autonomic nervous system when they go into opioid withdrawal. One of the organs they lose control of is the adrenal gland. And in our
Well,
last few minutes,
let me say something here. You wouldn't go out and tell me that I have cancer without doing a test on me. Isn't
no,
that
because
correct?
what you're talking about there, B, is uh, you're talking about failure to diagnose.
Yes, sir.
Okay, and failure to diagnose is one of the most common causes of malpractice. Now, whether or not this is malpractice, that's let's leave that up to the lawyers. Okay, but if these people are actually having genetic damage and autonomic dysfunction, which is what we call loss of control of the autonomic nervous system, if these people are actually having DNA damage and autonomic dysfunction, and you diagnose them as opioid addiction or opioid use disorder, and you missed the underlying diagnosis, yeah, that's failure to diagnose. Yes, yes, yeah,
Wow.
and we're not going to sit here and say whether it is or isn't malpractice. We will leave that up to the malpractice experts. But I will say this: if you're a provider out there and you've been diagnosing people with opioid use disorder or opioid addiction, uh, you might want to consider a plan of action. Okay, and in fact, we're willing to help the providers with that plan of action. You need to quite quickly tell your patients, tell your people. You need to tell everybody that you diagnosed with opioid use disorder and opioid addiction that there is now a DNA test. Now, currently, that DNA test is not reimbursed by Medicare, Medicaid, and the commercial insurances. That's going to take a long time. That's not in the immediate future. Okay, we're just now going through the CLIA certification process. So, if your patient wishes to have the DNA test, it's self-pay. It is not an inexpensive test. It is a $600 test. It started out a $2,500 test, and we feel good to have gotten it down to $600. But it's not a cheap test. But that's a discussion that we will save for later. I know you got to wrap it up here, Beeb. So let's just have some words of closure, and let's talk about where we're going to pick up tomorrow. You see in
Okay.
front of you 15 people who volunteered to have their blood drawn during opioid withdrawal. 13 out of 15, okay, the ones that have the gray boxes, Everywhere you see the gray, that's abnormal. 13 out of 15 had abnormal adrenaline levels. 6 out of 15 had more than one abnormal adrenaline levels. 2 out of 15 had the incredibly toxic combination of norepinephrine and epinephrine. And B, let's hold the advancing of our discussion right there for today. Tomorrow we will pick up with these abnormal catecholamines, and we will compare them to other groups of people and their catecholamines. So, B, in our last few minutes, any questions, any comments?
No, but I can tell you that the science, number one, does not lie. The blood tests, not blood tests, but the DNA tests do not lie. I mean, it shows you plain and clear that there is places where, as you put it the other day, that the light switch has been turned off. And once it gets turned off, who knows whether or not it would ever be able to be turned back on again. But yes, it is a very dangerous, as you have explained, to have these this problem going on without detection, without knowing that this is happening, because you can die of a heart attack or a stroke or anything when you're having this withdrawal. Anyway, I just think that these graphs and these tests that are being done are just immensely important. And I think anybody who has been exposed to opioids, who can't get off the opioid, needs to have the Smith DNA test and find out the fact that they are not a drug addict, that they do not have a brain disorder, that they have a problem with their DNA. Their bodies have been poisoned by this drug. And that's the most important thing. And that needs to get out all over the world. People need the help. It needs to be seen. And by going ahead, and I think it's very smart to do a class action lawsuit, it will go to the courts and it will be public. And once it becomes public, it will be known and it will be stopped. If they will get the proper treatment that they need to have, and hopefully the drug companies will pay for this treatment, which they need to do, because they're the ones that put it out there. They're the ones that did the damage to these people. And I find it really strange that they did this damage to these people and made billions of dollars doing it, and then they come out with another drug that helps them to fight the side effects of the first drug that they put out, and then they're making more billions of dollars. So anyway, I have nothing more to say except that people need to know.
Well, Dr. B, thank you. It was an honor to be here today, and I look forward to being with you again in the future.
Well, we enjoy having you, and we really appreciate you coming. I know it takes a lot out of your day when you're so busy, but thank you again.
Thank you, Dr. B.
Bye-bye.
Well, thank you so much for joining us with Live Talk with Dr. B. We are here every Monday through Thursday at 12:30, so thank you.